and testing the AllJoyn software framework. My name is Narayanan and I'll be the presenter. Mitch Williams is the host. I work for Qualcomm Connected Experiences and I work out of the Seattle office. So the agenda will be something like this. We'll focus on some testing areas for code contributors and for application developers. We will see how to do some basic unit testing. Then I'll show you a demo of some basic level system testing. Then we will focus our attention on to debugging, how to enable logging for AllJoyn, some basic test apps that you can use for end-to-end testing and also for debugging, some commonly seen discovery and connectivity related issues, some popular tools and miscellaneous points that we can discuss. What are the challenges for testers when they test AllJoyn? So AllJoyn is a diverse software framework. So by diverse I mean that it is implemented for different bindings. So we have AllJoyn for the C++ native bindings, Java bindings, JavaScript, Objective-C for iOS and OS X devices, C bindings, Unity bindings. We have the thin library for the embedded systems devices. Apart from that, AllJoyn runs on different platforms like the standard Linux distributions, Android on Gingerbread and higher versions, Windows, Apple iOS, Apple OS X devices, OpenWRT routers, and it is even going to run on the embedded systems like thermostats and refrigerators, etc. Apart from the platforms, it is transport agnostic. It has to work over several transports like the local transport, TCP IP transport, or the ICE transport, etc. So a tester has to test all these different things when he's testing AllJoyn. So some of the challenges are automation when it comes to testing, because for an automation framework might work for some platforms, may not work for the other platforms. So we might have to come up with a different scheme and things like that. So that is why it's always a challenge. So when it comes to testing, I would like to address two types of people. One who would be contributing source code to AllJoyn framework. Maybe they'll add some new features or they will enhance the existing framework code. And the other will be application developers who will be making use of the framework to develop cool applications. So when it comes to source code contributors, the areas of testing that an individual should focus on would be like unit testing, system testing, which is actual device to device testing for different platforms, some kind of stress testing, and backward compatibility testing. When it comes to application developers, the application developer will have to test their application left and right, and they also have to do backward compatibility testing. Backward compatibility testing is very important in this case because AllJoyn at the end is basically a distributed system networking application. It is going to run on several devices. People are not going to upgrade. I mean, some people may upgrade to the latest software, some people may just not upgrade to the latest software. What that means is that a new version of the software should work and should connect seamlessly to the older version of the software and vice versa. So which is why if a source, I mean if somebody is contributing something to the framework, or if it is an app developer who is taking the framework and developing an application, the backward compatibility test is very, very important. So now we will go and see the unit testing mechanisms that we use. So unit testing basically tests the different APIs that AllJoyn exposes, basically the public APIs. These are platform independent tests. What that means is that you don't need a real device or anything to run these kind of tests. These tests are basically run for all the bindings that we support. So all the bindings that are supported by AllJoyn have some kind of unit test framework. Like for example, the C++ bindings, they have the Google test running. The Java bindings, they have the JUnit test running, so on and so forth. These tests are not released as a part of the SDK, but anyone who is trying to build AllJoyn for any platform can use the const command to build the test, and it is advisable that they build and they run those tests. Any contributions coming from any contributor, they must run those unit tests as a part of sanity check to ensure that everything is working fine. Any new public API that is being added by any developer must have a unit test. They should test the different combinations of the API, different input parameters and things, and so on and so forth. The unit test should be reliable. By reliable I mean that it should consistently pass or consistently fail. Why I say is that AllJoyn is basically event-based software. There are several events that get triggered when you call an API. So it is not that we just call the API and check for the written code in the unit test. Basically, what we do is that in case of these events and when we call the API, are the events getting triggered properly or not? Are the events getting captured? So those are the things we also test as a part of the unit test. And since it is event driven software, these events can occur at different timing. For example, in an emulator which is very slow, these events can occur at these events may occur very slowly. If you are running the test on a high level OS which has significant amount of resources, the events may occur very fast. So at the end of the day, these tests have to run for optimum time and they have to be reliable. Basically, it should pass on all the platforms. So we will see like how to run the basic test. I'll show you like how to run the Google test and the JUnit test, which are the most prominent tests which we run on a daily basis whenever somebody checks in the code. So okay, so since these tests are not released as a part of the SDK, the only option to run them is to build the test. So I'm going to show you how to build and how to run the test. Okay, there we go. So I'm going to use cons to build. I am interested in building the 64-bit version of AllJoyn. I don't want to build any services because we are interested in testing the AllJoyn framework right now. With respect to the bindings, I want to build the CPP bindings and the Java bindings. I don't want any white space related problems. And I'm using Microsoft Visual Studio 2010 because that is the basic version that we support. And on top of it, I want to build the Google test, which is why I am specifying the Google test directory where the Google test files are stored. So it is going to build the source code and the test as well. So I have already done this build, so it is not going to take time building it, and we'll be ready. As you can see, the build has already finished. So at this point, we have built AllJoyn for CPP and Java. At the same time, we have built the Google test and the JUnit test. So let me run the JUnit test. So we use and it has a build.xml file that will trigger the JUnit test, and we have to give the options as the OS is Windows 7, the CPU is x86 64 because we built it for the 64-bit variant, and we are running it for the debug variant. As you can see, the test just got triggered and it is going to run several suites of tests. I think there are some around like 300 tests that get run as a part of JUnit, and anybody who is trying out any change to these APIs or anybody wants to try out a new build, they should definitely run the JUnit test and the Google test. It is advised. So we are into the auth listener test suite. It is going to run some authentication based test, and this will go on. So it might take around like 5 minutes for all the 300 tests to complete. Meanwhile, I'll also run the Google test. So the binary is ajtest.exe. So we can just start that. As you can see, there are currently 145 tests added, and it's going to run all the 145 tests. Right now, all the tests are passing. Okay. So as you can see from the output that is getting printed, we can see some things like found advertised name being printed. So these are the events that I was talking about. So we need to capture these kind of events as well. So if these events are not captured, then the test is not reliable. So as you can see, the test is obediently waiting for these events to get triggered. If the events happen, then we capture it and then we decode the results. So these are the events that I was talking about. Okay. Okay. So the JUnit test is also running. As you can see, it ran around 34 tests from the auth listener test suite. There are no failures right now, and the test will continue. Let it continue to run. We will revisit this after some time. So these are the basic commands by which you can run the Google unit and the JUnit test. Okay, so running the unit test should give you some amount of confidence with respect to the API testing, but we need to do some kind of system testing as well, because AllJoyn is basically a network based software. It's a distributed system software, so we need to run some tests between device to device so that we can see how AllJoyn functions. The basic aim of system testing is to ensure that we test the key features of discovery, connectivity, and message passing. Right now AllJoyn supports only the TCP IP transport and the local transport. So TCP IP transport means that the routing node can talk to the other routing node using the TCP IP mechanism, and local transport means that a leaf node can talk to the routing node via the local transport. So again, there are two components. One is a standard library basic system test, and other is the thin library basic system test. I'll demo like how to run these tests and what are the things that we should be looking for when we run these end-to-end tests. So for the standard library basic system test, the basic primitive applications are the VB service and the VB client application. So VB service, as the name suggests, is basically a service application written using AllJoyn, a service that implements a ping method that takes in an input argument which is a string and echoes the same string back. It requests a name and it advertises a well-known name as well. So the name in this case that we'll be using is AllSeen.alliance. The client, on the other hand, will try to discover the name, and once it discovers it over the network, it will try to join a session with the service application, and after that it will make 10 pings. So this is what we are going to demo today. So as you can see, the JUnit tests are going on. So at this point I'm going to pause this because it might take a while for the test to complete. The Google tests are also going on. Okay, so basically I started the VB service application with the name AllSeen.alliance. As you can see from the console that the VB service did start, everything got initialized correctly, and it is basically ready to accept connections from the client side. Now let me go and start the client application. Okay, so I just made 5 ping calls so that we can see all the output in one shot. So VB client did make 5 method calls and it exited with ER OK. So this is an indication that the system level testing, which is an end-to-end test, is working fine. So as you can see, when we started VB client, it printed out the AllJoyn library version, which is basically pointing to the 14.2 release that happened recently. The client tried to discover the service name AllSeen.alliance, and the discovery was successful because this event called found advertised name triggered. In this name we can see that it discovered, in this event we can see that it discovered the service AllSeen.alliance. The discovery happened over the transport port 4. 4 means that it is an IP based discovery, and after that we see a flurry of name owner change signals. What that means is that the names are getting exchanged over the bus. So VB service application is running a routing node within itself. So every instance of a routing node will have a unique ID with a suffix .1, and any instance of bus attachment you create will have a unique ID with a suffix .2, .3, .4 or .5. So in this case we have something called as .5, and then the service also requested a well-known name called AllSeen.alliance. So that name also appeared on the client side, as you can see here. So the names got exchanged. After that, the join session took place and it also succeeded. It took 227 milliseconds. So this join session created a TCP pipe between the BB client and the BB service application. After the join session succeeded, the client started making the method calls using the strings ping string 1, ping string 2, ping string 3 and a ping string 5. The same string were echoed. Oh, okay, it didn't get echoed here because looks like there is another service application that is running. So I'm going to quit. I'm going to run it again. Okay. Okay, there we go. Yeah, as you can see, all the method calls were echoed on the service side as well, and the service is just echoing back with the same string that came from the client side. After the 5 method calls were made, the client tries to fetch a property on the service. So apart from implementing a method, the service side also implements a property. The property is basically an integer. It has a value of 100. So the client tries to fetch the property, and after it does that successfully, it just tears down the bus attachment. When that happens, the session that was established before, it gets toned down, and when that gets toned down, you see another event that is getting triggered that is called as the session lost. The reason is 2. So 2 indicates that the other side closed the session, and when that happens, BB client exited with EROK. We don't see any errors. So this means that this end-to-end test passed successfully, and the TCP/IP transport is currently working fine. And the service will always, the service is never going to exit because it's a service. It is not supposed to exit. It should provide service to all the other applications throughout. So we can just go ahead and run the client application again, and it will work just fine. So we see an error here, an error that is coming from AllJoyn object, failed to send session lost with reason, and it is giving some status code. We can ignore that. The reason we can ignore that is because it is coming from the routing node, and our test application still exited with ER_OK. So that is a good thing. If it doesn't exit with the error code ER_OK, then we are running into some errors which you might need to debug. So let me go ahead and quit the service. So the service also exited with ER_OK. We don't see any errors, so we are good on that front too. Okay. So we executed a basic standard library system test using BB service and BB client application. So the next step is to execute a thin library basic system test. So we are going to execute the thin library test sample program, which is called service.lite. It is basically a light version of BB service, just that it is the program that will be running on embedded systems. As you all know by now that whenever we run an embedded system application, it first needs a routing node that it can connect to. So the embedded system application will connect to a routing node using IP mechanism, and in our case, the routing node software will be the sample daemon.exe that will be running. So the service lite and its routing node will be one such part which will basically simulate the service end, and then we'll be running BB client application as regular so that it will talk to the service lite. So this is what I'm going to show you. All these samples are released as a part of the SDK. So even if you don't want to build, you can directly pull out the SDK and run these samples if you want to do a smoke test kind of thing. So I run the sample daemon.exe, which is basically a routing node. It is waiting for a thin library application to connect to it. And the thin library application is nothing but the service lite.exe. So when I ran it, we can see that this line got printed: request credentials for authenticating using mechanism AllJoyn Phoenix. What that means is that the service lite application connected to the routing node by means of Phoenix mechanism. That means that this routing node supports only the trusted clients. On the service light.exe console, we can see that the service implements many methods and properties, and we are interested only in the ping method because VB client is just going to ping the service. And you can also see that it implements properties like an integer, string, and also a read-only property. We are only interested in the integer property because VB client wants to fetch only the integer value property. So at this point we have run the thin library application. It is also connected to a routing node. Now let's run the VB client application just like we did before. VB client AllSeen.aligns. -D stands for discovery, which means I'm telling the client, okay, go ahead and discover the service for me. So I'll do just like 5 pings so that we can see the output at one shot. There we go. So it is printing the library version as usual. Then it is trying to discover the name AllSeen.aligns. The event found advertise name indicates that it was able to discover the name AllSeen.aligns. After that, VB client went and joined the session. We can see a flurry of name owner change signals. It means the names are getting exchanged over the bus. After the join session was successful, we are now doing the message passing by means of method call. We made 5 method calls which were successful. After that, VB client tried to fetch a property which is basically an integer. You can see the integer value is 1 2 3 4 5 6, and it exited with er_OK. So this is how we can do a basic thin library system test. Actually, in real world, all these 3 components will be running on different devices. For example, the sample daemon.exe will be something that will be running on a OpenWRT router because it's basically a routing node. The service light.exe is a thin library application which will be running on some embedded systems like refrigerator or thermostat or toaster or anything. VB client.exe, which is basically a standard library application, could be running on an Android phone which is trying to probe and which is trying to talk to the thin library application. So in real world, all these things will be running on different devices, but we can simulate different devices just by opening command terminals and by running them as separate processes, and they will be talking to each other using the TCP/IP transport. So even though you don't have real devices to carry out testing, just by running these as different processes, you will be able to simulate the real device scenario. So the system testing is basically bindings independent. They must be done between device to device. Ideally, they should be done for all the platforms. Multiple devices can be simulated on a single machine, just like we did right now. Applications, they have the routing node bundled in them. For example, when we run VB service is basically a leaf node which has the routing node bundled in itself. When we ran VB client is also a leaf node which has the routing node bundled within itself, and these routing nodes, they talk using the TCP/IP transport. One cool thing is that AllJoyn now works over the loopback interface also. This is a new minor feature that got added in this release. What that means is that if you are in some kind of isolated environment where you don't have a real network, when all your real interfaces are down, if you just have the local interfaces that are up and running, the same test that we ran just now should work seamlessly. If you want to write a new system test code, all you have to do is go to the source code, place your code in AllJoyn_core/test, add an entry to the conscript file so that your code will be picked up, and when you do a build, your code should be compiled and it should be ready for testing. The type of testing that we do in system test won't be covered in unit test, so which is why the system test and the unit test are like 2 separate components. I mean, anybody who is developing an application or wants to do a sanity check of AllJoyn, who is contributing new code to AllJoyn, should run some kind of unit test followed by some kind of system test so as to gain confidence about the system. So here we reach a logical breakpoint as we have seen some of the testing mechanisms that we do and that any developer should do. Now we will jump into some of the debugging stuff and some of the basic things that an app developer or source contributor should know while trying to debug AllJoyn related issues. Before I go into this, you guys have any questions about testing? Okay, I assume that there are no questions, so we will go into debugging. Application can misbehave or can malfunction for an infinite number of reasons, and it is not possible to cover it's not possible to cover all the scenarios in this debugging session. So what we are going to do is we will see some basic things that a developer needs to keep in mind when he's either developing a new feature or when he's trying to develop an application using the AllJoyn framework. The first and foremost thing is basically the release variant versus the debug variant. So the debug variant is used in the initial stages when someone wants to learn about AllJoyn, someone wants to develop an application, and when they think that they would like to enable logging and they would like to see the AllJoyn logs and stuff like that. The debug variant is basically bigger in size because it has to accommodate all the symbol tables and stuff, and this is where logging is enabled. Logging is not enabled in the release variant, and you can actually decode errors with literals. When the error is printed, it prints out the whole literals, and from the message sometimes it is very clear what is going on. On the other hand, release variant just prints the error code. It gives the minimum amount of error logging. It is very small in size. It has to be used when you are going to deploy the application onto a production environment, or when you are going to deploy your app to the app store or something like that. Because for the final deployment, you don't want to use the debug variant as that is bigger in size. The release variant, which is a very trimmed down version, that is the one that should be used. So I have given an example as to how an error message will look in the debug variant and the release variant. As you can see in this slide, the error refers to socket binding failure because the port was already in use. From the debug error message, it is very clear because we can see the literal error message: binding failed, port 9955 address is already in use. The same error message, when it is printed in the release variant, we cannot make anything out of it. In fact, it even prints the error code and not the error literal. So in that case, what you can do is, sometimes when you have no other option but to debug with the release variant, and when you start seeing these error codes, wondering what to do, what you can do is that you can go to this file called status.h and you can do the error code lookup. So the status.h is also a file that is released as a part of the SDK. Let me quickly show you how the status.h file looks like. So if I just open this using Edit Plus, we can see it as a list of all the statuses, and if you see the error code 4, that refers to ER OS error. Underlying OS has indicated an error. This is the same error that we saw in the debug variant. So at times when you don't have access to the debug variant, where you cannot debug AllJoyn using the debug variant, what you can do is you can rely on the status.h files to look up the error codes and to get an understanding of what the message could be. The sconce build builds the debug variant by default. If you want to build the release variant, you have to explicitly say variant equals release. The SDKs that are released, they have both the debug variant and the release variant, so you can use whichever ones you want. Ideally, in the initial stages of the development of a feature or of the app, it is advisable to use the debug variant so you can debug at ease. Later on, as the application or the feature becomes stable, and when it is time to do a production deployment or release the app to the app store, you should test it with the release variant as well. So it is important to test it using both the debug variant and the release variant. Okay, then we come to another important concept, that is basically the AllJoyn logging. So AllJoyn logging basically works only for the debug variant. So there are several modules in AllJoyn, modules that are related to discovery, modules that are related to session management, modules that are related to session signals, threads, timers, etc. So depending on which module you want to debug, you can enable logging for that particular module. So there are macros to do that. I'll show you how to run how to enable logging when you're running a C++ application. But let's say you are developing an app and it's not a C++ application. So if you want to enable logging from specific module, you can use this API called as use OS logging and set debug level. Just set the module name from where you want the logs and set the verbosity level. 7 means that it has got very high verbosity. It's going to print all the things, debug, high level debug, print traces, etc. And if you don't want that much level of debugging, you can reduce the verbosity as well. So let me just show you how to enable logging when we run simple application. So let's say I don't know anything about logging. I want to capture logging from all possible modules. So I'm going to set this environment variable. So this all here basically corresponds to the all macro, which means enable logging from all the modules. Now let me run VB service application. This is going to be very slow because it is going to emit logs from all the modules and it's going to take time because it has to print all those things onto the console. There you go, and it is not yet done. It is continuously printing. And there are stuff that are occurring periodically, so it will continuously keep on printing. So this is not advisable unless you are redirecting all these logs to a file or something. So if you want to capture logs from a specific module or something, then you should use that particular module name. So let me just quit VB service. Okay, so as you can see, these are some of the module names. AllJoyn is a module name, and this is basically a debug statement that is coming from the AllJoyn module. This is basically a high level debug statement that is coming from the thread module. This is another module that belongs to the discovery. This is another module name that belongs to the discovery module. It is called as IPNS or IP name service. There is another module called as AllJoyn router, and the logs are being emitted from that module. So if you enable logging for all modules, one good thing is that it will give you an idea of what different kind of modules you have. Another way of finding out what different modules you have is directly if you open the source code, any AllJoyn related file will have a QCC module name, and that will give you an idea to which module it belongs to. I'll show you an example of that as well. So I go to the AllJoyn source code, I go to AllJoyn core, I'll go to the router, and let's say I open a file called sessionless_object.cc. So at the beginning there is a QCC module that is defined, and you can see the name of the module is sessionless. So if you do er_debug_sessionless equals 7, and if you run your C++ application, it will emit out logging information only pertaining to that module. So this is how you can find out different modules. Let me enable a specific module and see how we get logging from that particular module. First I want to set AllJoyn debug all to 0 because that's how it is done on Windows. In case of Linux, you can directly export this variable to whatever value you want. Since I came to know that AllJoyn_router is another module name, I want to capture logs from that particular module. I'll just set that and let me run VB service. Oh, sorry, I set it incorrectly. It should have been er_debug_AllJoyn_router equals 7. There we go. So now we have very limited amount of logging. Logging is coming from only that module that we want, and it is clearly printing different kinds of logs. This is a high level debug log. This is a debug log. It is printing out everything because we set the verbosity to 7, which means it will be highest. It will basically print out everything that belongs to that module. So I try to exit it, and during the exit cleanup, it again printed out several information pertaining to that module. So this is how you do selective module level debugging. Okay. Some more details about AllJoyn logging. So logging always has to be enabled either using the macro or using the APIs that we saw, and it can be controlled. It has verbosity levels, but error messages on the other hand, they are printed by default and they cannot be controlled, and which is of course right, because if the system is running into some errors, you need to notify the developer about these errors so that corrective actions can be taken. So which is why the error messages will always be printed by default either onto the logcat messages or onto the console where it is running. Some important logging module names are the all macro, just we already saw. It will print out debug information from all the modules. If you are debugging something related to discovery, it should be IPNS, that stands for IP name service. If you are debugging something related to AllJoyn messaging, it should be AllJoyn. If it is something to do with sessions management, it should be AllJoyn_obj. If it is something to do with sessionless signal, like we saw in the code, it should be sessionless, so on and so forth. And if you are not aware, you can always open up a file and see to which module it belongs to if you want to have debugging from that particular module. That was about AllJoyn logging. Now we focus our attention to another test app which is kind of our favorite. It is called as the Sessions app. It is a C++ test application. It is also released as a part of the SDK. You can also build it from source. Basically, it's an interactive app, and this is used to create AllJoyn topologies on demand. You can just run the app, you can configure it as a service, you can configure it as a client, you can discover all the names that are there on the network, you can join session to any service. Basically, on the fly you can make this app behave as a client or as a service. So it is a very useful debugging app that we use to debug AllJoyn, especially networking related stuff or connection related stuff, and it is interoperable with any kind of bindings. For example, a JavaScript application which is behaving as a service can interoperate with the Sessions app behaving as a client, or a Java app which is running on an Android phone which is a service can interop with the Sessions app which is running as a client. So it is very easily interoperable. So let me quickly show you how to run the Sessions app. What we are going to do is we are going to run two instances of the Sessions app. One will behave as a service, other will behave as a client, and then we'll show you like how they can interact with each other. So I'll just run Sessions, and it is interactive. You need to enter commands so that you can configure it as a service or as a client the way you want. It has got a very rich help menu with all the APIs that it supports. As you can see, you can do things like requesting a name, you can create sessions by binding and unbinding session ports, you can do discovery related stuff by advertising and finding, you can join sessions using the join API, you can send messages. Basically you can send AllJoyn signals by using the command chat. It also has a feature to test the sessionless signals, which is a very important feature these days, plus a lot of other stuff. So at this point I want to configure this app as a service. So as a service, what are the important things that I need to do? You need to request a name. So let me request a name. So the name that I want to request is hello.a. So we requested a name, we got a name owner change indicating that the name got approved. After that I want to host a session. So for that I want to bind a session port. So the session port I'm going to bind is say 25. Let's say I want to keep this a point-to-point session. So we have done that as well. So it is not throwing any errors, which means that the bind session port API did return successfully. After that I want to advertise the name that I requested because I want people to know that I'm advertising something. So I did advertise hello.a, no errors thrown by the API. It means that the name is also advertised successfully. So by doing these three steps so easily, we have created a service which requested a name, which has created a session, and which has also advertised. Now let's run another instance of the Sessions app as a client. Okay, so I have started the Sessions app. It is printing some debugging logs from the AllJoyn router module. We can ignore that. Now for a client application, the two important things that it needs to do is first discover a service. The way you can do is to use the find command. Okay, so I did a find by prefix hello and I got this event discovered hello.a. So this is an event that indicates, that tells the client that okay, I was able to discover the service. So that is half the part. After discovering a service, I want to join a session with that service. So the command to do that is join. I want to use the exact name of the service that it discovered. I want to use the same port. The service is using the port number 25 if you remember, and this has to be a point-to-point session. I press enter and you can see it joined the session. The names got exchanged over the bus. Join session succeeded, and we even have a session ID. On the service side as well, as you can see, it accepted the join session request from the other sessions app. The session ID got created, and both sides have a session form. They have the same session ID. So it is very easy to simulate, and the client and the service, you can use any names you want. You can advertise any names. You can request names. You can bind session to any port. Nothing is hard coded. It is very easy to create topologies on the fly. So at this point, I'm going to send an AllJoyn signal as a chat message using this session ID. There you go. It sent out a signal message, and if you see, the other side also received the signal in form of a chat, and you can see the message, hello guys, welcome. So this is how we can use sessions app. This is again a very basic app that you can use for any kind of system testing when you want to do end-to-end testing between devices. The other way we use this app as a debugging tool is to get onto the bus. Let's say I'm running these applications VB service and VB client. So I'm doing quite a large number of things, and this is going on now. Okay, so now what happened was VB service and VB client applications, they have already formed a bus. Now I can use this sessions app cleverly to just get onto the bus and to know what kind of things are going on, what are the names that are there on the bus, and we do that in this way. So I already know that there is a service that is running on a well-defined port. The name that the service is advertising is hello.a. So I want this app to behave as a client. So what I'm going to do is first I'm going to discover the service. It did discover. Then I'm going to join the service. The port is 24 because VB service uses port 24. I know, you can see the source code for that. There you go. Now this sessions app is on the bus, and on the bus we also have the applications VB service and VB clients, and the indication that this app is on the bus is the name owner change signals. So as you can see, there are 5 name owner change signals that are coming, out of which 3 are coming from the VB service side, 2 are coming from the VB client side. Hello.a, which is basically belongs to the VB service, that has a unique name :ADO something with the prefix .2. So the prefix, the suffix .2. So the name with suffix .2 belongs to the VB service, as you can see here, and the one with the suffix .1 belongs to the routing node of the VB service. Similarly, we have a unique name that has a suffix .1, and that belongs to the routing node of the VB client. That would be this guy, and the unique name of the VB client would be this thing. So as you can see, using this app we basically discovered the names that are there on the bus, and we actually got onto the bus also. This is how we can do debugging about different names. Another way to use this app is to just keep on doing discovery. Let's say you're running some services on the router or on some Android phones or any other device to which you don't have access to. All you can do is, if you want to find what kind of services are being advertised, just launch sessions from your machine where and the machine should be on the same network, and just try to do a search by prefix. So right now there are no other names, so it won't discover anything, but you can just discover by prefix, and it should give you the list of all the names that are being advertised with the prefix that are there on the network. The advertisements might be happening on an OpenWRT router, it might be happening from the embedded system devices, or it can be happening on any mobile devices. As long as this app is running on a device and it is connected to the same network, you will get a list of all the names that are being advertised. So this is a very good tool when you want to debug discovery related stuff as well. So we can use this app as well when you want to debug a lot of things. So we will now see some of the commonly seen discovery related issues. If you want to debug discovery related issues, you have to enable the module IPNS, and you will capture logs from that module and you can post it on the forum so that some developer can take a look into that. The first step when discovery is not working between device to device, the first step is to ensure that the AllJoyn application is correctly sending all the packets. That you can do by just enabling logs, because when you enable logs, when you are advertising something, it will show a list. I mean, it will basically give you the information as to what kind of packets it is sending from what interfaces. By default, AllJoyn will try to send packets over all the interfaces. In any interface, it will try to send three kinds of packets. One is basically an IPv4 multicast DEBUG packet with the destination address 224.0.0.113. The second is an IPv6 multicast PDP packet with the destination address FF02::13A, and the third is basically an IPv4 subnet broadcast UDP packet where the destination address is basically the subnet broadcast address. So you have to ensure by looking at the debug logs that for all the interfaces, three types of packets are being sent. If that happens, the next step is to ensure that you have to check whether there are any firewall rules that are blocking the packets from being received, or if the router has peer isolation, or if the router is blocking multicast packets or not. So you have to check your router settings, or you have to check the firewall rules and stuff like that. Maybe try receiving the packets on a different device so that the firewall rules may not be there and this query might work. What you can also do is that you can run Wireshark on another machine connected to the same network, of course, and you can see whether you can you are able to see the discovery packets or not. For example, if you run Wireshark on a third machine, you should be able to see the discovery related messages like this. And in the payload, if you see in clear plain text, you can see the names that are being advertised. So you can clearly see AllSeen.align name being advertised. The packet that I have highlighted is a packet that has destination address belonging to the group IPv4 multicast 224.0.113. Below that you can see direct subnet broadcast that is happening. Below that you can also see the IPv6 multicast that is happening. So all these three types of mechanisms you can see if you run Wireshark. Assuming that the discovery is working fine, then you might try to join a session from one device to the other device. Again, join session is nothing but initiating a TCP connection between two devices that can again fail because of several reasons. If you run into some kind of firewall issues where a firewall is blocking an incoming connection, you would see an error like this. You can see the connection is timed out, and the join session, the application gets an error back with the message join session reply unreachable. In some cases, you have exceeded the AllJoyn connection limit. For example, any AllJoyn application that you are running is going to have some kind of connection limit imposed on them, so that you don't run into denial of service attacks. So if you happen to exceed those connection limits, the subsequent join session call will also fail. As you can see here clearly that there is no slot for new connection. We have already exceeded our connection limits. Join session will still fail with the join session reply unreachable. Or join session can also fail if you are trying to join on an incorrect name. So one common mistake that we have seen is that people try to discover the names by prefix, and they try to join the session on that prefix itself, which is wrong. If you try to discover by prefix, that is okay, but when you try to join the session, you have to use the entire name of the service. Otherwise, you won't be able to identify the service, and join session will fail. Or in some other cases, if the service is binding on some port, and if you try to join session on a different port, your join session will still won't work. So you have to ensure that you are trying to join session on the correct name of the service and the correct port. Of course, the port has to be known beforehand. Some other tools would be the ICMP ping. If your ping itself is not working between devices, of course the devices may not be on the same network properly, and your discovery won't even work. So that is the first step that we do. Whenever we think that we need to test discoverability stuff, we see whether the AllSeen pipping is working fine or not. Then ifconfig or ipconfig basically shows you what kind of interfaces you have, just to give an indication that AllJoyn is good to run on both interfaces. Netstat is a very useful tool that we use if you want to see the TCP connections that are happening between the routing nodes. The first AllJoyn application that you run is going to occupy the 9955 port, and I need to show you that as well. Let's say we quit all these applications for now. Not running sessions app. So let's say I run VV service. So I'm going to use Netstat. So it is showing me a lot of things. But if you see, it has opened a TCP socket. It is basically listening on 9955 port. So the first instance of AllJoyn application you run on any device is going to open the TCP 9955 port. What that means is that the application is basically listening on this port for incoming connections. Any subsequent applications you run is also going to first try to acquire the 9955 port. It will fail to do so because it can't bind to that port. That port is already in use. Failing which, it will try to use an ephemeral port or a random port. So if you are trying to run the first instance of an AllJoyn application, you can always use Netstat to see that it opened the correct ports. This is basically for TCP connection. For discovery, it will open the UDP 9956 port, and you can see that it's basically opened the port for different interfaces, which is why we have like multiple entries here. So this is an indication that now you are good to do discovery and connectivity. The relevant ports are also open. So Netstat is again a very good tool that we use to debug. Wireshark or TCP dump is a very good tool if you want to debug discovery related information. If you run into any kind of crashes, or if you think there is some kind of deadlock or anything, GDB is a very good tool to show different AllJoyn threads and how they are interacting, what current state they are in, and things like that. Valgrind, Massive, and AppVerif are very good profiling tools. If you are developing a new feature and if you are making some significant changes to the AllJoyn source code, it is advisable to run some kind of stress test or some kind of longevity test using these profiling tools to ensure that we don't run into any memory leaks or any unbounded memory growth. So these are some of the important useful tools that you may use in future. Some miscellaneous stuff that I would like to tell is that like you should always check for API return statuses. You should not ignore those errors. They are like very important. If you want to separate the routing node errors from the library errors, what I would suggest is that you should run the routing node component separately. The routing node component is a software basically known as the AllJoyn daemon. It basically runs only on the POSIX based platforms like Android or Linux or OpenWRT. So it is, if at some point you think that the error is coming from the routing node and not from the library, and if you don't want to mix those things, it is advisable to run the routing node separately. It is not possible for all the platforms. For example, Windows or Objective-C or iOS based platforms, it is not possible to run the routing node separately because the apps can be developed with the routing node bundled inside that. So you'll get routing node errors and the standard library errors on the same console. So in that case, it's not possible to run them separately. If at all you are running a standalone routing node separately, ensure that you are running only one instance. I mean, there should not be any multiple instances of the routing node by accident, because that can lead to routing node initialization errors and your application will be in an OR state, which will be very difficult to debug. If you are running some kind of leaf nodes which wants to connect to the standalone routing nodes, ensure that you supply the proper configuration files, and the configuration files you should specify that you are supporting untrusted clients, because if you don't support any untrusted clients, the leaf nodes will never be able to connect to the standalone routing nodes. They can never find a routing node and things will never work for you. So these are some of the key things that you should keep in mind. For most of the things, I think you should be able to turn on debug logs. and if you post those things on the forum, somebody else will take a look at it and they can start debugging on those kind of things. With that, I think I'll leave the forum to you guys for any questions you have. Again, thanks a lot for attending the talk. Hope this was useful. So if you have any questions, I'll take the questions now.
Okay, so if anybody has questions, either please type them into the chat window or go ahead and unmute your mic and just ask the question verbally.
So I have a question from Chanhoon Dion. The question is, how can I test the about interface? So about now is basically a core service, so you need to build about with scons, which I have not included in this presentation. So the way you can do is, if you have the AllJoyn source code and if you have all the services source code as well, including about, in the scons build, if you specify about services equals about, you will be able to test about like this. I'll just show you. Not here. Okay. So if you see my scons command, I have not included any services, but if you include services equals about, it should build the about samples, and you should be able to test the about service and the about client. So the way to test that is, you need to have an about service that is basically going to announce itself. That about service can be a standard library about, or it can be a thin library about, and you should have an about client that will basically get the about notification and it can probe the about service for its properties. Any more questions?
Just a reminder, everyone, if you're trying to ask a question, make sure you've unmuted your mic. Okay, well, I guess if we don't have any more questions, I think that'll do it. Thanks, Nara, and thank you, everybody, for listening in. And if you do have questions after the presentation, if you think of them later, just go to the forums and ask them there.